All right, this is Chapter 5, Lesson 7, the final lesson in this chapter. All right, it's called Graph on the Coordinate Plane. The essential chapter question that we've been answering, and you should absolutely be able to answer at this point in time, is how are integers and absolute value used in real-world situations? Okay, I'm not going to answer that for you, but you should be able to answer it. All right, if I were to come up to you and tap you on the shoulder and tell you, hey, answer the chapter essential question, you should be able to with no problem. Okay, the lesson essential question is, how can the coordinate plane be used to represent geometric figures? Okay, I will answer the question eventually, so you need to bear with me and watch the whole video. All right, scavenger hunt. Maria hid the clues to a scavenger hunt for her hiking club. Use the map to show where she hid the clues. Identify the location of each clues. Now, you've been doing this already. Okay, that's what we did the last lesson, which was the coordinate plane, in which we looked at a coordinate plane and we identified points on it. Okay, now remember, points come up x, comma, y. I guess maybe I did not mention that clearly enough, but I know that we went over this before, so you should know that they appear in alphabetical order. Okay, just remember they appear in alphabetical order. All right, so the first clue is hidden near a tree. What ordered pair describes its location? First of all, let's find the dot that represents this clue. So we see it right there. I put a little red dot. Okay, we first had to figure out the x-coordinate. It's very important that we do it in this order. So we start at the origin. Always, can't spell, always start, S-T-A-R-T, at the origin. Okay, remember that. When you're plotting stuff, always start at the origin. Or if you're trying to find a point, always start at the origin. Okay, so we're going to start at the origin. We're going to go over until we reach the red dot, which is going to be 4. So I'm going to come over here and write 4. All right, and then we're going to go up to 2. You know, I'm going to spoil the surprise, and it's going to be comma 2. All right, and that's where that point is. All right, so x comes first, y comes second. Okay, you guys don't actually get to see me pointing at the thing, but I'm pointing. Imagine me pointing. Okay, Myra hid the next clue at a location reflected across the y-axis. Where is it hidden? Okay, it is reflected across the y-axis. That means the y point is going to stay the same. So we already know the y point. We also already know the x point because it's the opposite, right? Which is why the reason why I had that bell ringer yesterday, all right, is because we're trying to find opposites. It was 4, now it's the opposite of 4, which is -4. Okay, it is not 1/4, that's the inverse. All right. All right, 3. Now this one's a little tricky. I don't like the way they do this one. Okay, and let's go ahead and plot that point, -4, 2. So I'm going to use green here. So I'm going to go -4 and 2. Okay, so we're there. All right, she walks 3 blocks east and 2 blocks north to place the next clue. What they don't explain is that they're coming from that last point. -4, comma 2 is where they're at. So I will use a blue marker, and we will go over 3 blocks to the east. Now remember, every line is 2 blocks, so we have to go to here and then up 2 blocks, all right? And we come to the point, and where is it hidden? It is hidden at, we do x first, so that's -1, and then we do our y point, and that's 4, all right? Excellent, not too bad. All right, let me erase all this so it's not all cluttered. Ta-da! Whoop, I just grabbed something and twirled it around. It was fun. All right. The next clue is at a location reflected across the x-axis. All right. We already know the point that we're at, and so when it's reflected across the x-axis, right, that means the x stays the same. So we know the x-coordinate. Okay. And now we take the opposite of the y-coordinate. The opposite of the y-coordinate is -1, comma -4. Awesome. Okay, no big deal. So now it's also planted here. I'll do this with a black dot. It's kind of close to the playground. All right. Now, it said Myra hid the next clue under a rock by the lake. How many blocks east did she walk to the lake? Okay, again, this is not starting at the origin, which annoys me to death because that's what you would normally do is start at the origin. Okay, but since this is a map, you don't necessarily have to start at the origin. So remember, each one of these, a half a line is a block, so that's 1, 2, 3, 4, 5, 6 blocks. So she walked 6 blocks. I don't know if you really have to label it blocks, but we will. All right. So the final clue tells the hikers to walk 5 blocks north and 3 blocks east to find the prize from the last point that we're at. Because when you're walking around, you're not going to walk, when you're on a map, you're not going to walk all the way to the origin and start all over again. You're going to start where you last left off. So here we are, we want to walk 5 blocks north. So this is 1, 2, 3, 4, 5. So it's right there. All right, and then it says 3 blocks east. There is a compass on here if you are confused in what north, south, east, west looks like. It's right here. I'll erase it so it doesn't take up a mess. All right, but that's where your compass is. So east, she said what, 3 blocks east? All right, so we'll move 3 blocks east. That's 1, 2, 3, and I'll put a dot right there. That's where we want to be. Now we want to actually put the ordered pair there. Remember, we do X first. Now let me gently erase all this stuff. I don't want to erase the dot. Okay, try not to erase the dot. I will use again green. All right, so we go over X to 8, right? And then we go up to Y equals 1. And that's the ordered pair that describes location. Not hard, okay? This is not going to be a hard, challenging lesson to you. Unless you are a person who is not good with directions, then you will probably fail miserably, but hey, we'll work through that. That's why I'm here, right? Right. Okay, graphing ordered pairs. Probably the most simplest thing since adding, all right? To graph an ordered pair, draw a dot at the point that corresponds to the coordinates, okay? So we'd have this here, this example here. I don't even have to do any math. I love this because there's no math involved, right? Graph point M at -3, 5. Remember, it goes X, then Y, or alphabetical order, however you do it. And they show it here. They go -3, and then they go up 5, and they put the dot. Now, all you have to do, if it gives you a letter to label it, all you need to do is label it with the letter. You don't have to label the points. If they do not give you a letter, it would be wise of you to label the points so you don't have to continually try to figure out what that point is. Okay? Now, here we go. They graph N. Graph point N at -2.5, comma -3.5. All right? Now, if I were to ask you randomly, hey, what quadrant is point M at? You should be able to tell me that's in quadrant 2. Okay? Because if you know where quadrant 1 is and we're, counterclockwise, you should be able to tell me where all the quadrants are easily. It's not challenging to figure this out. As long as it doesn't appear on a x-axis or y-axis, it's very easy. And if it does appear on the x or y-axis, you should also be able to tell me what quadrant it's in. Okay, graphing point N. No big deal. Again, they go first. They do the x point first, -2.5, and then they do the y point second, -3.5, and you find out that it's right there. Look how beautiful that point is. It's a pretty point. All right. They ask you to do these problems. What I suggest that you do is you pause my video right here. I'll wait till you pause it. Okay, you've paused it, I hope. You can't pause it if you're listening to me right now, so hopefully you're back and you understand what to do. All right, again, when we graph these, x comes first, y comes second. 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 Alphabetical order every time. All right, so we got -2 and 4. I go over to -2, and then I go up to 4 and plot that. And that is my P point, okay? I'm going to use a red one, so I'm not going to erase these lines. It's going to confuse the heck out of you, but I don't really care. All right, Q is 0, right? That's our X point, and then we go -4 to the Y point at -4, so it's here. All right, I'll just draw a line straight down. And ta-da, that is our Q point, okay? Our R point, I'm going to do in green, is -0.5. So we go over here, -0.5. It's going to be right here, okay? And then we go up, and we go down, -2.5. So we go all the way down to this point right here. That is our R coordinate, all right? Our little grid here is getting very, very crowded, all right? The last one is S, which is 4.5, comma 1. X comes first, so we go right to 4.5. It's going to take us all the way over here where this arrow is. And then we go up 1 for the Y coordinate. And ta-da, what letter is that? That's S. Look at that. Beautiful. Beautiful. Easy. Simple. Should not confuse you. Although, if you don't watch my video, it will. All right. Graph reflections on the coordinate plane. We've already discussed this. This should not be hard. Okay? Remember, points reflected across the x-axis will have the same x-coordinate, and their y-coordinate will be opposite. Points reflected across the y-axis will have the same y-coordinate, and their x-coordinates will be opposite. Very simple. Very, very simple. Keep the idea straight. Whatever you're reflecting across, it's keeping that number, and it's taking the opposite of the other. It should not be very hard for you. Now, you're going to see this little A with an apostrophe. Okay? I'm just going to circle it real quick so you can see it. That A with the apostrophe is called A prime. Okay? It's not A apostrophe. It's called A prime. They don't actually even say what it is in the book, but that's what it's called. It's called A prime. All right. You graph A at 2, -4, which they do right here. All right? We don't have to graph it. And then they reflect it across the x-axis. If they reflect it across the x-axis, the x stays the same, and the y is opposite. It was -4, now it's 4. And that's where they plot A prime at. Not very hard. That's what they say here. Okay? If you are confused on this, please come and see me, because if you're confused on that, please don't, drive ever. All right. Graph B at -1.5, 3, then graph its reflection across the y-axis. They graph B for us. It's very simple. -1.5 and 3, excuse me. All right, and then they reflect it across the y-axis. That means we know the y point, okay? And all we got to do is take the opposite of -1.5, and that is 1.5. Hold on, let me pause the video because I'm going to cough my brain. All right, thank you for that. Sorry about that. I just almost puked my brains out. All right, back from being disturbed again. All right. All right, so what they want you to do is they now want you to do these. All right, let me get this little recording thing out the way so we can actually do it. Did I move it enough? Yes, I did. All right. Now, the way that we do this is, again, they want us to graph C at -1.5. Remember, it goes x then y. So -1 goes this way, and then they want us to go up to 5, all the way at the end of our graph. All right, we got to label it. It's C. Now, they want us to reflect it across the x-axis. That means our x point is going to stay the same. That number right there is going to stay the same. And then we're going to take the opposite of 5, which is -5. When we plot that, that's going to be C prime. All right? So we just reflect it, right? You got -1, x is -1, and then then y is -5, and that's your C prime. All right, for D is 2, 3.5. So we go ahead and graph 2, 3.5. I'll go over 2, and then I'll go up to 3.5. All right, and that's our D point. Now, they want us to reflect it across the y-axis. As you notice, I am actually underlining reflection across the y-axis. When I do that, what I'm doing is I'm emphasizing that, look, it's the y I'm keeping. So I'm going to keep the y at 3.5. Then I take the 2 and take the opposite of it, right? Not hard to do. So now we go -2 and then up to 3.5. And that is our D prime. D prime. The reflection is the prime. I know you might actually get that backwards, but don't. We don't put a little apostrophe on things unless we're making a copy of it. All right? This is the last one. This is the essential question. Okay, the less than essential question that's going to be answered. All right, Mr. Martin is using a coordinate plane to design a logo. He graphs points at 2, 4 and 2, -2. He reflects 2, -2 across the y-axis. He reflects across the y-axis. That means his y is going to stay the same, and the 2 is going to turn to -2, or the x is going to turn negative. Then he reflects the new point. He reflects the new point. So you're going to need to write down the new point. We're here at -2, -2. All right. He's reflecting across the y-axis. So that means the x-axis. Sorry. He's reflecting across the x-axis. So that means our x is going to stay the same. So our new point is going to be -2, 2. So we're going to take the opposite of -2. What figure is Mr. Martin using for his logo? Now, you may be out of geometry for last year. You may have forgotten what that shape is. But that shape is called a trapezoid. Okay, that is a trapezoid. It has two right angles followed by 2 non-right angles. One acute, one obtuse. You don't remember what acute is? Acute angle is acute and small, and a obtuse is bigger than 90 degrees, and an acute is less than 90 degrees. Okay? Now, as you notice, this let him build a trapezoid by just reflecting some points. Now, when we do this next problem here, they're also going to build a geometric figure. Okay? So pause the video, do this on your own, see if you can figure out what figure is graphed on the map. And you can kind of see how it's graphing it, right? Now, not all figures are going to work like this. Okay? Not all figures are going to work like this, but most figures will. Okay? Miss Shaw is drawing a map of the school. Her room is at -3, 4. So we'll go ahead and go to -3, 4, right? I'm going to label the points since it didn't give us an A, B, C, or D. All right? So I label that. The gym is at 3, 4. I'm going to go to 3, 4, and put it. Now, I can either label that as the gym, or I can go ahead and just put 3, 4, which it doesn't really matter. Okay? Then it says the library is a reflection of 3, 4 across the x-axis. So that means our x is going to stay the same, right? And that means our y is going to be negative. So we go over here to 3, -4. I have a classroom full of people here that are watching this video and cannot stay still. So forgive all the noise in the background. Okay? So this is 3, -4. All right? Then it says this point is reflected across the y-axis to graph the office. Okay? So we have her room. We have the gym, or the gym. We have the library. And now we're going to plot one more. Okay? This point is reflected across the y-axis. The point we're reflecting is the library, okay? So it's being reflected across the y. That means our y stays the same, and we take the opposite of the x. All right, go ahead and let's graph that. So it's -3, 4. That's right here. This is -3, 4. It is also, -4, I apologize. And this is the office, okay? Either one of these ideas is okay to label it. If you just want to label it office, her room, gym, library, that's fine, okay? But you want to make sure it's not written where I wrote office at, and I'll show you why in just a second. So off to the side here, office, O-F-F-I-C-E. Now it says, what figure is graphed on the map? We start at the point that she started at. We start at this point, and then go to this point. So we go -3 to 4 to 3, 4. We go down to 3, -4, and then we go over to -3, -4, and back up to our original point. Then it asks, what figure is that? That is a rectangle. Now, some of you might actually call that a square. That is not a square, okay? A square is a rectangle, but a rectangle is not a square, okay? Recognize that. Now, let's go back real quick. I'm going to go take a look at the essential question real quick, so let me pause the video. Now it says, how can the coordinate plane help you represent geometric figures? I've done it in 2 ideas. As you notice, all we got to do is plot things through reflections, and that'll give you easy 90-degree angles. Okay? Now, if you don't do it through reflections, and you just start plotting points, you can also do it that way. The hard geometric figures to do like this are going to be circles or anything with a curve. Okay, you're gonna have to use some other way of doing it. Okay, you don't want to do that type of geometric figure. But anything that has nice angles to it that are easily done, like triangles, rectangles, squares, trapezoids, all those they can be easily represented on here by either using reflections or just graphing the points. Just take the actual shape and put it right on top of the grid, and then start plotting points. Okay, so either one of those 2 ideas are good answers. All right, that's it. That's the end of the lesson and the end of the chapter, right? If, when finished watching the lesson, either put your name stick in the help bucket and start doing your notes, or if you think you can move on, put your name in the guided practice bucket and do the guided practice page 406 all. Once done with the guided practice, see me to check it over. Once I tell you, you can do the extra practice. It's page 409, 410, odds. Please stop asking me if they are all of them or the odds. I always issue the odds. I'm telling you, it's annoying. All right, I'm going to start issuing lost detentions if you come up to me and start asking me about stuff that I've already said in the video. All right, thank you, love you, good night. Good night.